So let's get started with creating our very first shell script. So I would use VA editor to create these scripts, but you are welcome to use any other editor with which you are comfortable. But try it out by using a command line editor so that you can open a terminal, and within the terminal you edit the script and also try it out. How does it function? So where am I right now? I am in my home directory. So let me start writing some script within this directory itself. So I start opening a file using the VI editor. So I would say my script 1, so S1, and usually most of the shell scripts should have some ending so that immediately we can recognize what type of a file it is. So sh is an ending for bash scripts, so we will have that as our file extension. And I can start typing by first entering the insert mode. So I press I to go to the insert mode, and then as a custom I would also mention that it's a shell script, so I would write as bin bash. Okay, and then I can start writing some commands here. So I can add some comments for my own reference. So we can say s1.sh is my first script. Okay, and I would just simply like to echo something. So I would say hello world, and then I'm done with that. So I escape colon and then WQ. Okay, I'm done with that now. So let us check what does this contain. It's a very small script, and you see that the default file permissions are such that there is no executable permission, and we can already try it out by sourcing it. Okay, so we will source it by using the dot command dot s1.sh. So what it would do is the shell would read the commands listed in that particular script and then execute them. So you see that it has gone through, executed the command which says echo hello world, and I mentioned to you that source is a nickname for dot, so you could also write source s1.sh and then the same effect will be seen. Now we will go on to check whether they are actually running in the same shell or a different shell when we run as an executable. So for that we need to edit it, and so let us go and try that out. So I would say the PID of the process running this script is okay, and then I would like to mention the PID there. Okay, so now we are actually checking the value, inbuilt value of the $$ variable, which is the process ID of the script which is running. Now we would actually, so first let us just check what would be the PID of that particular bash shell. So it says 6446. So I would type PS, and you can see that the bash shell that we are currently running has a PID of 6446. Now when I source the s1.sh, it shows you the same PID number, which means that when you source a script, then the lines that are contained in the script are executed within the same shell as what we are logged into and running the script from. Now we would like to execute this, and if you try to do that by giving the path, so current directory /s1.sh is the correct way to launch it, but when you do that you are expected to see an error. The error is that permission denied. Is it because we are not the owners? That's not true. You can see that we are the owners, but there is no executable permission, and that's why the error has come. So we already know how to give ourselves the executable permission. So I'm giving 755. So that is full permissions for mine, the owner, and then read and executable permissions for the group and for others, and on the file name s1.sh. So then we go and see the permissions. So there is an executable permission available, and therefore we now should be able to execute this using the command s1.sh. Okay, and when you run, you see that the output is very similar. The hello world has been output correctly. The second line of echo is also output correctly, but the PID number is different. So which means that when you did this, what happened is that when you typed ./s1.sh, the bash has spawned another child shell in which this script has been executed, and the child shell has the PID number 10,955. Now we can actually confirm this by typing commands which show us the process ID properly. So let us do that now. So you know the outcome of the ps minus minus forest. It will tell you what are the processes that are running and which one is launched by which other process, etc. So let us try the same command from the S1 also. Okay, so I just put it there like that. So cat s1.sh, so that it's there in front of you what it is doing, and we now execute it, and you can see that 11107 is the process ID of s1.sh, and 6446 is the parent process ID, and which is a parent, so the shell that we are currently logged into. So you can see that when you execute a script using dot by s1.sh, then a child shell is created, and therefore it is actually running as a separate process, and then once it is completed, the control is returned back to parent shell. So if you happen to make any changes to the variables or environment within that particular shell, then those will not be effective now. So let us just try that out. So I would create a variable here. So my var is equal to, okay, and let us say give some string, okay, and I would like to export so that the variable is actually available with any other shell after it. But we would actually see that if you see my var, it's empty. I type s1.sh, it is executed, and now I execute by actually displaying the content of that shell. So my var is actually available. Then I will also now try if it's available within my parent shell, and you see that it's not available, which means that any environment changes that were done in a script that is executed will not be available to the parent shell. But if it was sourced, it will be available. So let us just check that out now. Source s1.sh, and you see that it is actually doing the same execution, except that the process tree, you can see that it is not a subshell, but it is actually directly in the same parent shell, and therefore if you now see whether the variable is available, then sure enough it is available. So this is very important to understand that the way you run a particular script, is it sourcing or is it executing, and you must be very clear which one of the two types of behaviors is what is required for you. Now let us go ahead and try certain other features which tell us about the inbuilt variables that are available with, let us say, the $* or $1, $11, and so on. So let us just try that out. So I will actually have the comments to illustrate what is being displayed. So I would say I am invoked as, okay, and then we would have $0. So $0 is supposed to be the name of the file with which we have invoked this particular script. Okay, so let us go ahead and run it, and you see that it says the way we have invoked. Now where are we? We are in the home directory. So we can also run the script using the full absolute path, and you see that when you run it as an absolute path, the way it was invoked is also changing. And in fact, you can go elsewhere and then try it out also. You can go to, let us say, user bin, and then from there I would use a relative path. So when I go this way, I have gone up to the root, and then I come down, and then I can run the script, and you see that whichever way you have invoked, that particular string is being displayed. So it is one way by which within the script you will know whether you have been invoked with a relative path or an absolute path, or without any path information also. Now let us look at certain other variables. So I just keep this output there itself for the name of the script. So we will also go ahead and check out how many arguments have been passed, and if the first argument is available, let us go ahead and print it, and I can say here echo number of arguments passed to the script. And here I would say echo first argument passed is that, and then I would use escape y enter to copy the two lines and then print them here, and then replace cw to replace the word second argument, and here I would use r to replace one single character 2, and therefore we have edited the lines by copy paste in VI editor. So now let us go ahead and try this out. Now I don't pass any arguments, so it says that there are 0 arguments passed, and there is no error when you want to try printing out the first and second arguments. They are not available, so it's a null. That's all. Okay, there is no error out there. Now we can give the words as follows. So you can say argument 1, and you see that the number of arguments passed is 1, and it says that the first argument is arg1 and the second argument is null. So now I put arg2, and you see the second argument is coming out quite nicely. So when we actually pass on, let us say -l file, then how the shell knows the arguments that we are passing on is actually through these variables. So it knows that -l is one of the arguments and file is another argument, and the sequence with which they have come is also known because we know the positional placement of the arguments on the command line. So to know that, we can actually write it in a different manner, and you see that the first argument now is file and second argument is -l. So the shell actually knows what are the arguments you have passed and in which sequence, and therefore it can take certain action within the script to handle those options accordingly. Now if you want to pass arguments where the blank space is not to be interpreted, you could also do that by using the string possibility. Now you see that arg1 space arg2 is actually passed as a single string as a first argument, and then the second argument is null. So you could actually compare that with the behavior here, where arg1 and arg2 are two different arguments, the first and second arguments namely. So therefore you can see that the way you have to work out is by ensuring that the space has to be recognized as a default field separator. Now you can also override that. Now let us start looking at certain loops also. So we have already learned some of those in the lecture, so let us go ahead and try that out now. So we will test whether the first and second arguments are same. Okay, so if test, then $1 is the first argument. Is it same as $2? Okay, and if it is same, then we would like to say the two arguments are same. Okay, phi. Okay, if they are same, it will tell that they are same, but otherwise nothing else. Okay, so let us just try this out. And hello, and you can see that it has recognized the two arguments and it's also telling that they are same. Now let us say I type hello and world. So the second argument is not the same as first, and therefore that particular loop has been ignored because we are not entering the loop. And I'll just show you. So this part, then and then phi, this part we are not entering because this particular test condition has been false because the two arguments are not same, and therefore nothing is happening with respect to the execution. So after the echo of $2, nothing much has happened. Okay, so this is how you can actually check. Now you can also check how many arguments have been passed. So here is the way I have modified the script a little bit, where we are first testing for the number of arguments, and if it is less than 2, then I want to give an error. So let us just check that out how it works, and you see that the second argument is not there, so there's an error that says please pass more than 2 or equal to 2 arguments. And if I actually pass on the argument, if I pass on 2 arguments, then the error is not displayed and both arguments are now displayed. So you see how we have edited the particular script, where we have made the operator usage minus GE, that is greater than or equal to. So only when the number of arguments is greater than or equal to 2, then we would like to compare the first and second arguments. So otherwise we would not like to compare. And so let us see how this works. So you see that the two arguments are taken and compared, and the output that the two arguments are same is working out quite well. And let us say we give different words, then that particular check is not passed, and therefore we are not having the statement coming from the nested loop. So let me just show the script here. So you see that we are entering this part here only when the arguments are same, and we are not entering the loop at all if the arguments are less than 2. So let us try that out. So we are just not even entering the loop if the arguments are less than 2. So that way the script is slightly better to handle the situations where there are 2 arguments or more and the trying to compare them, etc. Now let us try to write another script, s2.sh, in which we would like to explore some other kind of loops. So bin bash, and here is where I would like to just simply try to use a for loop. So echo use of for loop, and what I would do is for then I in, then I need to give a list. So we can say arg1, arg2, arg3, then do echo $i done. So this is a very simple kind of a script. So let us just try this out. Chmod 755 s2.sh. Now when we run, you see that all the 3 arguments have been printed one after other, because the loop here is working to just do only echo. Okay, and each of these are treated as separate values in a list of 3 elements separated by a space, and therefore I is assigned the values that are in this list, and then that particular value is printed out. Now this list can be provided not just by having spaces and typed in, but it can also come from any variable or output of a command also. Let us try that out. So we have already the shell expansion possibilities, so using the double dots. So let us try that out. For example, file underscore, let us say, and we know that the braces can be used to have the expansions. So I would have 1 then double dot 9. Okay, so cat s2.sh. So you see that what has happened here. Okay, so underscore and then the brace expansion has been used so that you go from 1 to 9. So file 1 up to file 9. So we have actually started using the brace expansion to automatically create a list, and then from that list every element is assigned as a value to the variable I, and then that variable is being printed onto the screen. Now you could also combine this with other kind of expansions that we are familiar. So you would see that we are actually having 2 expansions, and this means that from A to D and 1 to 9, so that is 4 into 9. Okay, so 36 lines have to come, and let us see if that is the case. So you see that from A1 to A9 and then B1 to B9 and so on up to D9 has come. Now how many lines have come? So 37. Thus the 37, because this is the additional line, so 1 plus 36. Okay, so you can see that the brace expansions can be used quite well along with the other features of the shell. Now you could also do it with respect to the command output. So ls is a command for which we have the output that we know. So what we would do is using the expression like this, ls/bin. Okay, now every file that is located in the /bin directory will be available as an element of the array, and then that will be assigned to I, and it will be printed onto the screen. So let us try that out now. And you see that the list of output coming from the /bin directory is being shown. And we can now go and edit this command ls/bin in a way that would help us to reduce the output. So I put /z star. Okay, so that means that I want only those files in the bin directory which are starting with a Z character. So you can see that all the files in the bin directory starting with Z are listed here, because in our script we are saying ls/bin/z star. So this command has been executed. The output, which is what we have seen here, available as a array in this line, and therefore I is assigned a value for each of these elements in the array, and then that is getting printed onto the screen using the echo command. And this particular feature, command substitution, can also be achieved using the back ticks, which I am just showing you now. See that the output would be identical. Okay, so either back ticks or dollar followed by single parenthesis can be used for command substitution, as we have illustrated right away. Now, one way by which you can learn about shell scripts is to actually look at some shell scripts that are already within the Linux environment. So how do we find that out? So let us go to the bin directory, and there are many files here. Okay, so one of those commands which we know will help us to understand whether the particular file is a script or a binary is the command file. So file and then znew. So you see that it says there's a shell script. Now what we would do is pipe it to grep, which we have already seen in the recent class, to look for some pattern. So here we will say shell script is the pattern. So I would like for that, and if it was available, it would actually print it out. Now let us say I use it for something else, file zoom, and it says it's a symbolic link. So the pattern shell script is not appearing in the output of the command file, and therefore if I were to pass it on with this, then what happens is that there's no output, so null. So which means that I can actually use the combination of a file command on every file name, pipe it to grep, and ask whether it is a shell script to understand whether it's a shell script or not. So let us find out how many files in the /bin directory are actually shell scripts. So for that we will go ahead and write a shell script. Okay, echo shell scripts in /bin directory. Okay, now we need to run through all the files that are in /bin. So for that what we do is, for then the file is let us say I in, and then the list of files in the bin directory I need. So I would actually use it like this. So this is a loop, and what do we need to do? So first of all, let us just echo the file name to check whether the list of files are coming properly, and we would also then type it out, the command that we were doing here, file $i grep shell script. Okay, so let us just try this out, cat s1.sh, to just see what is it that we have written. So for every I in the list of file names in the /bin directory, what you have to do is print the file name and then get the output of the command file on that file name and pipe it to grep to check whether the output contains the phrase shell script, and if it contains, then print that out. So because the file name I is coming relative to the /bin directory, we need to put /bin in front of the $i, so that the file name is given with the full path, and therefore the file command would then work correctly. So let us go ahead and try this out. Okay, so here is what the script is run. So /bin/file name, and that is the file that is being processed with the file command, and then we are grepping the phrase shell script within the output of the file command on that particular file, and if it is successful then there will be a line that is displayed, otherwise only the file name is displayed. So let us try this out, and you see that the file names are all getting processed and some of the files are getting the output which we are expecting. So let that finish. So you could see that there are a lot of files that are actually scripts, and let us go ahead and limit the output by not echoing the file name and directly listing only what are actually shell scripts. So now the output will be a little bit less. So let us go ahead and try this out. Cat s1.sh. So you can see that what I am doing is I am not echoing the file name. I am only displaying the text if it was a shell script, otherwise don't do anything. So you see that now the output will be much less and only the shell script names are being displayed on the screen. Okay, now how many lines came, you could also analyze that, and you could pipe it to a file and then find out how many scripts are there, and then go on to read each of them to understand some of these features that were used by the Linux operating system. You could read these shell scripts to explore various features of the bash scripts as they have been used by the Linux operating system itself, and do not use super user permissions to modify any of them, because you are not supposed to touch them unless you know what you're doing. You are welcome, of course, to copy them to your home directory and modify them to see how do they work, but do read the man page for that particular command to see actually what are they supposed to do. Now I would also show you that we have some shell scripts that are processed automatically, sourced automatically when we log into the bash shell. So here is one such example, bash rc in my home directory, and this actually has various commands that were being run when I start the bash shell, and it has loops, it has the if loop, case loop, it has aliases and so on. So you could actually read these kind of scripts to actually see what are the features that are used in the bash scripting language, and then go on to explore some of those in your own scripts.